So good afternoon everybody, myself Acharya Vishvendra. Today I'll discuss some videos on the change of state. So for example, melting or boiling. So melting is the conversion of solid state to liquid. Boiling is from liquid state to gas. So generally melting and boiling points are taken at normal atmospheric pressure, that is 1 atm. There are certain standard facts. Melting point of ice is 0 degree, boiling point 100 standard. Now there is one important question. With increase in pressure, boiling point increases, freezing point decreases. With decrease in pressure, boiling point decreases and freezing point increases. So reverse is the impact. If we see the phase diagram of water, then it follows a curve as shown in the figure, as you can see over here. So this region corresponds to when water is solid, this corresponds to when water is liquid, and this state corresponds when water is in vapor phase. And the point at which these three graphs intersect is called the triple point of water, at which water coexists in all the three forms. It is at 611 Pascal and at a temperature of 273.16 Kelvin. Now this point where solid and liquid phases meets, this is called the melting or the freezing point. The point where liquid and the boiling point meets, it is called the boiling point. And the phase where solid and vapor phase meets, this is called the sublimation point. And we can see that from here, if we increase the pressure, suppose like this, so temperature is gonna increase, so boiling point will increase with increase in pressure. Similarly, if we decrease the pressure, then you can see the dotted lines over here, they will shift down, so the boiling point will decrease. Whereas if studied for the freezing point, you see if pressure is increased in this way, so with increase in pressure, you see the curve shifts towards left. As you can see over here, the curve will, if we move from here to here, then certainly the temperature will shift towards left. That means temperature will decrease, which shows that on increasing pressure, the melting point decreases, which is shown over here. And similarly, the boiling point decreases. So this can be analyzed. Now we have ideal gas equation, PV is equals to nRT. These are the parameters. And one important thing, a gas behaves like an ideal gas at high temperature and low pressure. Now let's discuss. This is the Boyle's law. PV is nRT. So if temperature is constant, number of moles constant, then PV is constant. So P proportional to 1 by V. Graph between P and V will be rectangular hyperbola. P and 1 by V will be a straight line. If we have 2 points A and B, then P1 V1 will be V2 V2. In the graph we have this tan theta. Tan theta here is if we draw the graph between P and 1 by V, then tan theta here will be proportional to n into t. If theta 2 is greater than theta 1, then n to t2 is greater than n1 into t1. This we can analyze from this. Then we have Charles' law. Charles' law is that if pressure is constant for a constant number of moles, then volume is proportional to temperature. So tan theta from here will be V by T, which will be nR by P. So tan theta proportional to 1 by P. Next is if we are given three different graphs, then corresponding to the highest angle, pressure will be the least. So corresponding to P3, pressure will be lowest, and corresponding to P1, pressure will be highest. Then we have Gale-Lussac's law that if volume is constant, pressure proportional to temperature, so is P is nR by V into T. So here tan theta is P by T, which is nR by V. So we can say that tan theta proportional to 1 by V. So if for corresponding to greater angle, volume will be less. So if we have three different graphs, so corresponding to the greatest angle, we have the least volume. So this we can analyze from these graphs. So as you have seen, we have content the lecture content of about 50 to 60 minutes in a duration of 5 to 6 minutes. This is just to optimize your time and energy. If you have any doubt, you can ask in the doubt section. Thank you and have a nice day.